Today we are doing the last lesson in Module 4, Writing Inequalities. And let's see here, because I am not on the screen on my Promethean board. That doesn't affect you watching it on the computer, but I need to be able to. And it's going to keep beeping at me. Okay. So how can you use inequalities? So inequalities, let's review, are they're right here, the less than symbol, the greater than symbol, the less than or equal to symbol, or the greater than or equal to symbol. And really the key is you want I don't want that. The greater value, and if it's written this way, you have the greater value on this. So if you forget which is greater than or less than, we always talk about like a little crocodile mouth or a Pac-Man open towards the number that has a larger value. So the low temperature ever recorded in Florida was -2 degrees. So we've done graphing before. -2 would be a dot right there. The temperatures of 0 degrees Fahrenheit, 3 degrees Fahrenheit, 6 degrees Fahrenheit, 5 degrees Fahrenheit, and -1 have also been recorded. So let's look at this. So 0, 3, oops, I didn't want that to do that, but 6 and 5. Okay? So since these are all greater, all of these are greater than -2. We draw a line. Anything that is larger value than -2 is a possible temperature. Okay? So how many other numbers? There's infinite numbers, and we could write this as x is any number greater than, and in this case, -2 is also part of this line, or equal to -2. That's just a little overview to the concept that we're doing. So let's look at it in some problems. So graphing the solutions. So a solution of an inequality contains a variable. Variable is a letter of the variable that makes it true. So for example, 7 is greater than -2, so that's a true statement. So let's look at these. We're going to, it says y is less than or equal to -3. We're going to put a dot at -3. And I tell students, think of a number that would make this true. For example, is -5 less than or equal to -3? Or is 5, because it's on the other side. Well, 5 is not less than, that's not true. This one is true. So we want an arrow to the left. Okay, and they talk about this, choosing a possible solution. If there's no equal sign as part of the inequality, as part of the inequality, okay, then you draw an open circle, okay? An empty circle, open circle. So M, so right now I'm going to put a circle on M. I'm going to think of what would make this true. So for instance, 1 is less than 3. That's true. So since the dot is to the right of this open circle, I'm going to draw the arrow. Okay? So let's look. Inez says you can rewrite this. Well, let's think. 1 is less than 5. So what we're going to do is substitute a value that makes it true, and that's a 5. So let's look at it this way. If we use 5, So that's true. How is, okay, so this one, x is less than 5, and an x is less than or equal to 5, it can include the value of 5. And that should be a 5. Okay? So moving on. Okay, so try this one. How would you graph the solution to the inequality? Let's look at this. Well, I'd go to -4. Since it includes the equal sign, it'd be a dot. Let me think of a number that, oh, well, -10 is less than or equal to -4. That's a true statement, so -10's out here. So the arrow would go that way. Okay? So write an inequality that represents the phrase, the sum. I don't know if we did this one in class, but let's look at, we can do this. Y and 2 is greater than 5. In order to do these, we have to go back to what we learned last lesson on getting rid of addition, subtraction, multiplication, division, so that we, hold on, I'm gonna sneeze. Excuse me, what we call isolate the variable. So how do we get rid of the 2 on this side? We subtract, we subtract 2 on both sides. And then we can do that. So there is, it's an open circle because there's no equal to. 4, 5, 6 are greater than 3. So what does that mean? Okay. Let's look at B. To test the temperature rating of a coat, a scientist keeps the temperature below 5 degrees. Okay? So the temperature, we're going to use T for temperature, has to be less than 5. So the temperature could be 4, it could be 3, it could be 2. Those are my examples. I should have written this. We start at 5. It's an open circle because there's no equal to sign. We go left. Okay, so let's try your turn. Write an inequality to represent the phrase, the sum of 1 and y. So y plus 1. Actually, let's do it in the order that you would probably do it. Because when you're looking at this, you're probably going to say 1 plus y is greater than or equal to 3. So there's no sign here, so that must be addition. There's like a little invisible plus sign. So I'm going to subtract 1 from both sides. Y has to be greater than or equal to 2. Okay? 1, that's not true. So it's 1 is not a solution. Okay? Let's erase this. Yeah. Write and graph an inequality to represent a situation. So the temperature in February, I'm just going to put it like this, was at most 6 degrees. So if 6 degrees was the most it was, examples are the temperature could have been 5, could have been 4, could have been 3. Those numbers are less than, okay? So what's tricky is at most, could it be 6? Well, it says the most it could be is 6, so I'm going to say yes. It's an equal to sign. So I'm going to close the circle there. And we said it could have been 5, it could have been 4, it could have been 3. So as I start making those dots, I know how to put my line. The next one, each package must weigh more than 2 ounces. So over here, it could be 3, it could be 4, it could be 5. Okay? It could not be 2 ounces because it has to be more than. So no equal part. So it has to be an open circle. So what are things that are more than 2? 3 is more than 2, 4 is more than 2, 5 is more than 2. Start to see which way my arrow should go. So now is where your teacher or you, if you're watching this at home, can pause the video and then work on these guided practice questions and then rewatch them. Turn the video back on and check your answers. So I'm going to go through this. Graph 1 is less than or equal to x. Okay? So when you go to 1, it's going to be a closed circle. And 1 is less than x. So I need a number that would be bigger. So for example, 2, I wanted this here. Whoops. 2 is bigger, 3 is bigger, 4 is bigger. So it would go that way. Okay? So -1, not a solution. 3 is a solution. It works. 0, not. And 1 is a solution because it has the equal to part. Okay? Check the graph using the solution. Let's see here what we do. -3. So it's an open circle is greater than z. So I need numbers where that's larger and this side is smaller. So things like -4, -5. And since I started dotting that way, it goes to the left. Write an inequality that represents the phrase, the sum of 4 and x is greater than 6. So for these, we need to subtract 4 from both sides. X is greater than 2. So it needs to be, let's leave it purple. An open circle, because there's no equal to sign, 3, 4. Okay. And then I'm going to just erase this here. During hibernation, a garter snake's body temperature never goes below 3 degrees. Okay? So let's start here. Never goes below 3. So it sounds like it could include 3. So 2, 1, 0 are below 3, but they tell me it never goes below 3. So things that are not below 3 are like 4, 5. Okay, so it is, the 3 is greater, it could be equal to. And let's see this last one. Write an equality to representation. Nina wants to take at least $15 to the movies. So the question is, and this gets confusing, at least. So think about it this way. Which works, 14 or 16? If she takes $14, that's not at least. So she wants to take, let's say she took 16. That would work. That's greater than. And you would also include the equal sign. So I think that should have helped you with how to do these.